So that is that for this question. Moving on to the next one. We look at another geometric series, which is given to us as the sum from n is equal to 1 to infinity of e to the n divided by 3 to the n minus 1. Okay, and we are asked to basically check if the series converges, and if it does, what's the value of r. Immediately that tells us that, and as we can see, that this is a geometric series. Well, the problem already tells us that, so we don't even have to rewrite it. And we know that for geometric series with the general form of n infinity ark, we know that for the convergence, absolute value of r has to be less than 1. So what is r in our case here? Well, first of all, we need to rewrite the series as it's given to us into that general form. So the series is given to us as the sum from n is equal to 1 to infinity of e to the n over 3 to the n minus 1, which can be rewritten as e to the 3 to the n times 1 over 3, right? Now we have the general form. That means that of absolute value of r is just equal to the absolute value of e over 3, because r is equal to e over 3. So since we know that r is equal to e over 3, that eliminates option 2, option 3, option 4. We're left with two options, 1 and 4, sorry. Not, that would be option 5 here. So 1 and 4. And if you take the absolute value of e over 3, that's just e over 3, which we know is less than 1. Right? What does that mean? Well, it means that our series converges. And which means that the correct option here is option 4. Since the absolute value of r is less than 1. Because remember, e is some value equal to 2.7 something. So if you divide 2 point something with 3, you get something less than 1, which tells us that the series converges. Okay, so that's done. Looking at the next one, we are given now we're given a geometric series, right? It really is the sum of two geometric series. Rather, well, not the sum of two geometric series, but it's an overall geometric series. That's just the sum of two series, individual series. And we are asked to check which one of the following statements here is true. And it's all pertains to the convergence of the series. So we have to basically check the convergence of the series. Well, as the sum is given to us, right? So we have the sum from n is equal to 1 to infinity of 5 over 4 to the n plus 10 over n, which can be divided into the sum of two separate series, which is the sum of one geometric series, which is 5 over 4 to the n, plus the sum of a p series, right? A p series, which is equal to 10 over n. Remember that, so this is the geometric series, which we are familiar with, and this is a p series, which, if you remember, a p series is a series of the form 1 over n to the p with n going from 1 to some value infinity, right? And there are different rules in terms of what the value of n of p, sorry, should be for the series to converge, right, or diverge, right? So, but one rule that we know is when p is equal to 1, then we have that the series is equal to n as the sum as n goes from equal to 1 to infinity, and that gives us 1 over n, which is a special case of the p series called harmonic series. So harmonic series are just p series where p is equal to 1, right? And a characteristic of harmonic series is that they always diverge. So they diverge. Well, since we know that basically the p series here, which is a harmonic series, diverges, right? We have to look at what happens to the geometric series now. Is it converging or diverging? Well, if we consider it separately, the sum from n is equal to 1 to infinity of 5 over 4 to the n, in this case, we have that r is equal to 5 over 4, right? Meaning that the absolute value of r is equal to 5 over 4 as well, which is greater than 1. Oh, no, sorry. That's my mistake. R is not equal to 5 over 4. R is equal to 1 over 4. Because 5 is not to the exponent of n. So 5 is our constant in this case, a. So R is equal to 1 over 4. The absolute value of 1 over 4 is just 1 over 4, which is less than 1. Which means that our geometric series converges. So we have one side that is converging and the other side that is diverging. Meaning that the sum of the two series now, immediately, as soon as you know that, it diverges. As soon as you have one of the series that is diverging, then the overall series is diverging. So what does that mean? Well, it means that the options that say that our overall sum of our series converges are eliminated. So that's 3 and 5. The options that tell us that they diverge are then considered, but the options that tell us that they diverge because the first series, which is our geometric series, diverges are eliminated. So that would be option 1. That would be option 4 as well. Because we know that the only series that diverges is our p series or the harmonic series there. So the only option left is the option 2, which is our correct answer. Okay, so hopefully this makes sense. Moving on, we are looking at the next question, which is asking us now to look for the limits of the sequence here given, which is n minus 1 times n plus 3 divided by 3n squared from n is equal to 1 to n is to infinity. Right? So we are asked to find the limit of the sequence. How do we do that? Well, we take the limit as n tends to infinity of the sequence that's given to us, which is n minus 1 times n plus 3 over 3n squared. And immediately we know that we have to divide in the numerator and denominator by the highest order, but before we do that, we have to expand the numerator. So we have the limit as n tends to infinity of n squared plus 3n minus n minus 3 divided by 3n squared, just equal to limits as n tends to infinity of n squared plus 2n minus 3 divided by 3n squared. So the highest order there is 2. So we have to divide by n squared in the numerator and denominator. So doing that, we have the limit as n tends to infinity of n squared plus 2n minus 3 divided by n squared, all divided by 3n squared divided by n squared, which gives us the limit as n tends to infinity of, in the denominator we have 3, the numerator we have 1 plus 2 over n minus 3 over n squared. Substituting the value of n as it tends to infinity, we have that in the numerator will be left with 1, denominator will be left with 3. So we have found our limit to be 1 over 3. Okay. So as n tends to infinity, the sequence is converging to a value of 1 over 3. Okay, so moving on to the next problem, we are given a sum we are given a series in the summation form, and we are asked to find the sum of the series. Well, how do we do that? Well, first we need to separate this into 2 series. So that would be now the sum as k goes from 1 to infinity of 1 over 5 to the k minus the sum as k goes from 1 to infinity of 1 over k times k plus 1. Now the first series is a geometric series. Right? Geometric series. Here we have a series with a quadratic expression in the denominator, which means that we will be using partial fractions to find this sum. But for this series here, the geometric series, the first one, we know that to find the sum, first we need to determine, is the series converging? Well, r is equal to 1 over 5. And the absolute value of r is 1 over 5, which is less than 1. So it is converging, right? Now the sum, since the series is converging, is just a over 1 minus r. And a in this case is just the first term of the series. So the first term of the series divided by 1 over 1 minus r. So the first term of our series, as k is equal to 1, is 1 over 5, divided by 1 minus 1 over 5, which is equal to 1 over 5 divided by 4 over 5, which if you simplify correctly, should give you 1 over 4 is our answer. Okay, so just give me a minute to check on something. Right. Okay, so that's our sum. Our sum is 1/4. So now we have to find the sum of our second series there, which is the sum from k is equal to 1 to infinity of 1/k times k plus 1, which we have to, if you use partial fractions, to separate this into the sum into two fractions, you'll find that this is just equal to the sum as k is equal to 1 to infinity of 1/k minus 1/k plus 1. Right. And immediately, since you have that, what is the sum equal? Well, we have to look at the how the term change. So the terms change. So the first term is 1 minus 1/2. The second term is 1/2 minus 1/3. The third term is 1/3 minus 1/4, and so on, right? All the way up until the second to last term, which is just 1/n minus 1 minus 1/, because we know that we are getting higher and higher to values close to infinity, and for now let's just represent that value as n, right? We'll take the limits just now as n tends to infinity to see what actually happens as you get closer and closer to infinity. But let's just say we get to some arbitrary very high value n, right? So now the second to last term will become 1/n minus 1 minus 1/n, right? Plus the last term, which will give us 1/n minus 1/n plus 1. And obviously, as you continue closer to infinity, there's some terms that add up. But what's more important is at this point here, as k tends to n, you can clearly see that 1/2 will cancel with that one, that with that one, 1/4 with the term that just comes after it. And as you go, if you go all the way to up to n, you'll see that this will cancel with that as well, right? And you will be left with, and you know that the 1/n plus 1 will cancel with the term that comes right before it, right? And therefore, you will be really left with two terms, 1 and minus 1/n plus 1. Okay, that's what the sum would look like. But now we need to take the limits of this as n tends to infinity, because remember, our sum is going all the way to infinity. So what happens to the sum as n tends to infinity? Well, as n tends to infinity, right, you will be left with only 1 there, because you'll have 1 minus 1/infinity, which is 1. Right? So as you add more terms, the sequence will just converge to 1, basically. And what that means is that the overall sum now, which is the sum from k is equal to 1 to infinity of 1/5k, 5 to the k, sorry, minus 1/k times k plus 1 is just equal to the sum of the first series, which we found to be 1/4, right? Remember, minus the sum of the second series, which we found to be 1. And that just gives us then negative 3/4, which is our final answer. Okay. Right. So Moving on to the next question, which is asking us to check what the divergent test tells us about the series that's given to us there. Well, we are given the series as k goes from 1 to infinity of root k over root k of plus 1, plus 2, sorry. So the divergent test would have us take the limit of this as k tends to infinity of the root k divided by root k plus 2. And what happens then? Well, when we divide by root k both in the numerator and denominator, you'll have 1 in the numerator, and you'll have 1 plus 2 root k in the denominator. And as you substitute with the value of k as it gets closer and closer to infinity, you have 1 over 1, which is equal to 1, which is different from 0. And what that tells us is that since this limit is different from 0, that the series diverge. That is based on the divergence test. So the series diverge. Okay. So the next question is asking us to use the ratio test to investigate the convergence of the series. Well, so what's the ratio test? Well, we remember that for the ratio test, we have to find a of k and a of k plus 1, right? And then we have to divide them and take the limits of that. So a of k plus 1 is just the same as a of k, but you substitute wherever you see k, you just substitute by k plus 1. So a of k plus 1 will just be k plus 1 factorial divided by k plus 1 to the k plus 1. Now, if we divide these two, if we take the limits as k tends to infinity of a of k plus 1 divided by a of k, we have the limit as k tends to infinity of a of k plus 1, which is k plus 1 factorial, divided by k plus 1 to the k plus 1, divided by a of k, which is just multiplied by the inverse, multiplied by k to the k, divided by k factorial. Okay, so since we have that, we can see if we can simplify some terms. The limit as k tends to infinity. We know that k plus 1 factorial is just k plus 1 multiplied by k factorial. And multiplied by k to the k, all divided by k plus 1 to the k, right? Multiplied by k plus 1, right? We can divide, separate those two like that. Multiplied by k factorial, okay, in the denominator. Now the k factorial can cancel there. And we can put together the terms to the exponent of k, right? Which will give us the limit as k tends to infinity. Oh, yes, and we can also cancel here k plus 1 because you can see that those two are cancelable. So we are left with really k to the k in the numerator and k plus 1 in the denominator. All of this to the exponent of k. Right? And now we remember the rules of the limits. If we have the limits of some function to some exponent, we can just take the limits of the function to and then just take the exponent of that limit. So we can bring in the limits inside the brackets. We have the limits. Or before we even do that, we can just divide by k in the numerator and denominator, because that's the highest order, right? So we have 1 divided by 1 plus 1 over k, all to the k. When you multiplying that exponent, you have the limits k tends to infinity of 1 over 1 plus 1 over k to the exponent k. And since we have the limit of a quotient of two functions, you just take the quotient of the limits. The limit of 1 is just 1, divided by the limits is k tends to infinity of 1 plus 1 over k to the k, which this is a standard limit, which we know to be equal to e. So we have the final answer is 1 over e. Okay, so that is our final answer, and that's the value that it's converging to, 1 over e. All right, so that is it for the session, for the problems that we had to look at. And hopefully the session was helpful for you guys. And yeah, hopefully you can use it to understand the concepts and make it a little bit more easy to chew, so to speak. Right, so thank you so much for attending. I'll see you guys in the next session. And yeah, keep trying, keep practicing. That's the only way you can sort of understand these problems. And feel free to pause the video at any time along the way, so you can attempt the problems before you look at the solution, right? So that should be helpful. Okay, thank you so much. I'll see you guys in the next one. Bye.